so that those who cannot join, they can look back the video. Is it already? Stop share, please. Okay. So first step, you find the YC from the homogeneous system. Okay, can you all still see, right? Okay, the screen that I shared. Okay, if you cannot, just okay, you can just WhatsApp me, okay, or just message. If any things that, let's say you cannot see the screen or any condition happens. So first step, find the complementary function YC from the homogeneous system. So first step A, you solve the determinant A minus lambda I equal to 0. So determinant, okay, A minus lambda I, the effects at the main diagonal. So means the matrix A initially is -3, -4, 5, 6. So determinant, so it's a straight symbol A minus lambda I. So effect at the main diagonal, you minus with lambda. And then you find the determinants, as you know that you have the product of the main diagonal. Okay, which is takes a -3 minus lambda multiplied 6 minus lambda here. So minus the product with the other diagonal. So minus 5 times -4 minus positive. So positive 20 here. You expand the bracket here. So -18 plus 20, you have 2 here. And then here -3 times negative lambda, so positive lambda. Okay, with minus 6 lambda. So positive 3 lambda minus 6 lambda, that's why we got minus 3 lambda. So minus lambda multiply minus lambda, positive lambda squared. Okay, so you have this one is either you can use your scientific calculator or this you can just factorize it and you can get lambda 1 is 1, lambda 2 is 2. So this is the first step, finds the eigenvalue. Okay, the following step, you find the corresponding eigenvector. Sorry. So for lambda 1 equal to 1, solve A minus lambda 1 I. Sorry, this one I 4. You have A minus lambda 1 I E1 equal to 0. So again, okay, from the previous here, this is determinant. You just change it to the matrix, which is a bracket. So minus lambda. So put it your lambda 1 here. Okay. And then put lambda 1 is 1 here. That's what you get here. So -3 minus 1, you have -4. 6 minus 1 is 5. Okay. From row 1 or row 2, you notice that it's actually both row are reduced to the same equation. Because if let's say row 1, if you divide by -4, let's say row 1 you divide by -4, it's actually you reduce to 1, 1. If row 2 divide by 5, you get back 1, 1. So mean these two rows is actually equivalent, because sometimes in the solution you see that I write row 1 equivalent to row 2, because it's actually reduced to the same equation. So it's either you use row 1 or row 2, or both equations, you can simplify it to x plus y equal to 0. Either you take the first row or second row. Okay, so x plus y equal to 0 or y equal to -x. If you let the x is s, then y is -s. Okay,
ரெண்டு ஈக்குவேஷன் சேம் ஆக்குதுங்க. சோ ஒரு ஈக்குவேஷன் வந்து பாதி இன்வெர்ட் பண்ணனும், இன்னொரு ஈக்குவேஷன் பாதி இன்வெர்ட் பண்ணனும். பண்ணீங்கன்னா ஈக்குவேஷன் x+y வந்துரும். சோ அதுக்கப்புறம் நீங்க செய்யலாம். சோ நம்ம அங்கதான் மிஸ்டேக் பண்ணுவோம்.
Okay, so here the xy, you have x is 1s, y is negative s. Taking s equal to 1, taking s equal to 1, then you will get v1 is 1, negative 1. Or if you let the y is s, then x will be negative s. So you may have another version of answer, mean v1 is negative 1, 1. So both are acceptable, both are equivalent. And then step 1c for lambda 2 equal to 2, you plug in lambda 2 is 2 here, 2 here. So negative 3 minus 2, you have negative 5, 6 minus 2 is 4 here. Okay, against both row are actually same. Reduce to the same row, means the row 1 are equivalent to row 2. Row 1 equivalent to row 2, because if row 1 to divide by negative 1, we get 5. This is 4. This is still 0. So row 1 equivalent to row 2, or I said both equation actually leads to 5x. This is 5 times x plus 4 times y equal to 0. Okay, in the V2 also you have I think 3 variations of the answer. Okay, my variation of answer will where I eliminate of the fractions form. If I let the y equal to negative 5s, okay, and then x will become 4s, because when you add up, y is negative 5s, so this total you have negative 20s. So x is 4s, so you have 20s. So 20s minus 20s, you get 0. So my x is 4s, y is negative 5s. Or you may have another variation, or you may have another versions that you let x is negative 4s, x is negative 4s, then y will become negative 5s. So means the V2 also you have maybe you have first row is positive, second row negative, or another variation is negative 4, this is positive 5. Or some of you you may have another version, let's say 4 over 5. If you don't let this one, maybe if you let x as a title, then you have, let's say x is negative 4 over 5 y. Then if you let y here equal to s, y is s. So mean you have another variation of answer is actually your y here is 1, then x is negative 4 over 5. Okay. This one, if you multiply by 5, then you have similar to this variation. This negative 4, this will become 5. Means if you multiply by 5, both row you have to multiply by 5. So you get another one, negative 4 and 5. So the eigenvector, you can have a variation of answer, but all are equivalent. Then after you get V1 and V2, the complementary function YC is A Y1 plus B Y2, or A B1 exponent lambda 1 is 1, so exponent 1x plus B V2 exponent lambda 2 is 2, so exponent 2x. Okay, step 2, you're finding the particular integral. Okay, your vector g from the questions is 5 exponent x minus 6 exponent x. Hence, for undetermined coefficient method, we choose a yp same form with your with the g, same form with g. In here, exponent x, the yp we choose also exponent x. Since we have used AB here, we use AB, so C and D. Okay, after you choose the YP, you have to check whether the YP clash with YC. Exponent X here will clash with the first term, also exponent X. So they are clash. Okay, in the second order non-homogeneous equation, we said that when clash, we multiply by X. So here, you can try to assume that the correct YP is, let's say, CD multiplied by X exponent X. And then you differentiate it, okay? So you differentiate the YP. Here you have to use a product rule. It means you have to use a product rule where this is the U, this is the V. U and V. Hence, the solution that I give here, this is V U prime plus U V prime. So this is a Y prime P. Then you plug in the Y prime P into the non-homogeneous system. Y prime equal to AY plus G. Here. This one, plug in here. CD exponent X plus CD X exponent X equal to, equal to this is A. The Y is actually Y replaced by your YP, CDX exponent X. Okay, remember you have the AY plus, this is the G, AY plus G. Okay, after that you do the metric multiplication of A and Y. Okay, A is a 2 by 2 matrix. This is 2 by 2 matrix. Okay, and this is a vector 2 by 1. Hence, you can multiply A and Y. A and Y. The result is 2 by 1 vector. So this is a 2 row 1 column vectors. Okay, and this vector is is depend on the term X exponent EX. Okay, so I just multiply A and Y. So to do the metric multiplication, first row times first column, you get the first row, first column, the first row here. So negative 3 times C plus negative 4 times D here. Then you take second row, 5, 6, 5, 6, let's change other color. 5 times C plus 6 times D. So this is the second row. Okay, and this one, this is G. This is put it here. G. And then you compare the same term left side, left hand side, right hand side. If you compare the exponential term, exponent X, so you notice that C equal to 5, C equal to 5, then D equal to negative 6. Okay, this one I jot down, both equation here I jot down as equation 1. Then you compare the X exponent term. Hence you have here negative 3C minus 4D equal to C, and then 5C plus 6D equal to D. Okay, you solve the equation 2. Collect the same term here, select the same term to your left side. Hence you have, this is negative 2C, sorry, 4C minus C, negative 4C minus 4D equal to 0. Okay, and then you have another one, 5C, 6D minus D, so you have plus 5D equal to 0. Okay, and then if you add up these two, so from equation 2 here, after you simplify here, or you add up these two also can, 5C minus 4C, you have C actually plus D equal to 0, or C equal to negative D. However, from 1, from 1 is comparing the exponential term, you already obtained C is 5, D is negative 6. However, if you compare the X exponent X, you get C equal to negative D. If C 5, then D should be negative 5. So mean 1 and 2 are actually contradict each other. Okay, so mean here from equation 1 and 2, they are contradict each other. That's why means if the exponential term are clash, here, this one clash. If your YP, initially you choose CD exponent X. If clash, you cannot just simply multiply by X only, like what you did in second order non-homogeneous equation. Okay. Then what you should do is actually, if the exponential term is clash, what you have to do is actually, you have to choose your YP is CD X exponent X plus EF exponent X. Then we repeat, we redo the same process again. Then we find the y prime p. So we differentiate the first term here. First of all, you differentiate x, we have 1. And then differentiate exponent x, we still have x exponent x. So this is actually, okay, this term is actually u v prime. This is a v u prime. And then differentiate the second term, you still get back the same, because differentiate exponent x, you get exponent x. And then you collect the same term, which is collecting the exponent x term. So you have c plus e, b plus f, exponent x plus c dx, exponent x. Then you plug in your y prime p into y prime, plug in the yp into y. So your y prime, okay, will be c plus e, b plus f, exponent x plus c dx, exponent x. Okay, again, this is a metric A. Okay, y now is c dx, exponent x plus ef, exponent x plus the g is 5, negative 6, exponent x. Again, okay, here the difference with just now, we have here the y, you have the x exponent term plus the exponent x term only. This is x, the product of x and exponent x. Okay, okay, the red color here is similar with just now. And okay, and then this part, the second vector here, exponent x, we have here is actually negative 3, negative 4, you multiply with ef. Okay. In this one similar with just now, so I erase it. Okay. Now you have here this one, negative 3 times e, negative 4 times f. So negative 3e, negative 4f. This is actually exponent x term, and then I collect with this 5 for first row. Okay, if second row, then you use second row time here 5 times e plus 6 times f, and then collect with this term negative 6. Okay, later on you collect, okay, you compare the same term. First you compare the x exponent x like just now. Okay, so negative 3c minus 4d equal to c. Okay, 5c plus 6d equal to d. Okay, you're solving the 3, you'll get, okay, like previous where you get the contradict equation. Means put c here, so you have negative 4c minus 4d. Okay, from here you collect your d, so you have 5c plus 5d equal to 0, leads to c equal to negative d. C equal to negative d just now. Here, same. And then you compare, later on you compare the, you compare the exponent x term, the blue color. So negative 3e minus 4f plus 5 equal to c plus e, 5e plus 6f minus 6 equal to d plus f. Okay, here, this one you correct it, because I use a previous template. So you compare the exponent. This is exponent x. Mean the exponent x term, c plus e equal to negative 3e minus 4f plus 5. Okay, you bring all the variable to the left hand side. So you have c minus, so minus 3e becomes c plus 4e plus 4f equal to 5. Then from 6 here, so you bring 5e plus 6f to left side, so become d minus 5e minus 5f equal to negative 6. Okay, and just now you already obtained c equal to negative d. C equal to negative d. So you substitute c, the d or c equal to negative d or d equal to negative c into the second equation of 7 here. So d here by negative c. If you add up these two equations, so c minus c cancel, so 4e minus 5e, negative e, 4f minus 5f, negative f, 5 minus 6, they have negative 1. So I multiply by left side, right side by negative 1, so you have e plus f equal to 1. E plus f equal to 1. So you can see that we have two unknown but left to only one equation. Actually, we have C, D, E, F. C, D, E, F. C, D, E, F from the x exponent x term, we only lead to C equal to negative D. From the exponent x term, then by plug in D equal negative C, we left to only one equation. So two unknown with one equation means we have a infinite many solution. Okay, in this case, if I let F equal to S, then E will be equal to 1 minus S. So in this case, you have actually a variety of solution. The easiest one, if I take S equal to 0, if I take S equal to 0, means I will take F here 0, then E is 1. Or you may take E 0, then F is 1. Okay, or you may have others, solution, means you may take, because S is a parameter, where I can take different value. So the easiest, I take 0. If you look at module, there will be another way of solve it. In the answer, you have a variety of answer there. Okay, so I take F equal to S equal to 0, so the E is 1, F is 0. So I obtain E and F. I need to solve C and D. So plug in. I want to find C here, right? So my F is 0, E is 1. So you have negative C. So negative 5 left to right side. So negative C equal to negative 5 plus and negative 6 plus 5. So C equal to negative 1, or C will be 1. And we know that D is equal to negative C. That's why D is equal to negative 1. So that's why I get C1, D, negative 1. So the particular integral yp will be C is 1, D is negative 1. So CD x exponent x plus EF. Or you may take the E0, F is 1. Okay, and the general solution is a YC plus YP. Okay. So this is a V1 exponent, lambda 1 is 1, so exponent 1x plus B, this is V2, exponent, lambda 2 is 2, 2x plus, this one is your YP. Okay, for YC, maybe some of you have another variation. Okay, your first row is negative, second row is positive, also can. Okay, B maybe, okay, first row here is negative 4, second row is positive, or equivalent fractions number also can. Then okay, if we maintain the YC here, then you have another variations where you take E0, F will get 1. Okay, this is in the matrix form. If you want Y1, then you take up all the first row in A exponent x plus B exponent 2x plus 1x exponent x plus this is 0 exponent x. For Y2 is negative A exponent x minus 5B exponent 2x minus x exponent x plus exponent x. For general solution, you may have a variety of answer. But if you plug in the initial condition, okay, your A, B will be different, okay, will have a different value because depend on your coefficient of your V1, V2. But you expand to get your Y1, Y2. Lastly, the particular integral, you should have the same answer. But in general solution, you can look at have a variation of answer. Okay, this is in the from exercise 3C question 1A. May I know, okay, okay. So is it? Where is it? Okay, this one is I think the tutorial, the homogeneous system, the question 6. But in PDF here, I don't have the marker. So this one, you have the y prime equal to phi negative 4, 0, 1, 0, 2, 0, 2, 5, y. This is homogeneous system. So first step, you solve determinant a minus lambda I equal to 0. Okay, and here you have to, this is a 3 by 3 system. Okay, to solve the determinant, normally you can take any row or any columns, any row or any columns. Actually easy. Next time I should take actually first column easy because this coefficient is 1. But I already took first row. So if I take first row, okay, I have here phi times phi minus lambda, and then multiply, okay, in the mix of, if you take first row, so phi minus lambda, and you cross the first row, first column, you left the determinant negative lambda through phi minus lambda. And then the second row, okay, to calculate the determinant, the sign from the, okay, the first row, first column, the sign is positive, later on negative, positive, it go down negative. So negative times negative 4 becomes plus 4. And to get the determinant of 2 by 2, you cross first row, second column. So you left 1, 0 through phi minus lambda. Then you expand the determinant of that 2 by 2. Okay, lastly, I think you'll get negative lambda cube plus 10 lambda squared minus 25 lambda equal to 0. Okay, if you use a scientific calculator, they may give you, okay, 2 root only because you have one repeated root. So how to determine whether the repeated root is 0 or 5? Okay, because how you determine the if you use the scientific calculator in this case, we don't have that coefficient like just now. That's why here I factor out that I will get 2 roots. Because I said, okay, if you use scientific calculator, you have here 2 roots, and then you can try either let's say you put in, this is lambda minus 5, and then you expand totally. Last time we have the constant term, but this case don't have. So another way, here you can, like this case, I factor out. So it's here 25, so the repeated should have, is 5, or you factor out. So first step, you get the eigenvalue. So you have 3 eigenvalues, 2 are repeated. So first step, for lambda 1 equal to 0, you solve the a minus lambda 1 I p1 equal to 0. So this is a minus lambda 1 I, because your lambda 1 is 0, so you get back the same matrix A. Then V1 x, y, z equal to 0 vector. Okay, here you can notice actually row, it's not easy to see whether row 1 equals to row 2 or equals to row 3. So we have to reduce, okay, the row, the row, second row, first column, third row, and first column become 0. Okay, the third column, third row first column already reduced, already 0 there. So you just need to make the cell A21 become 0. And then what I did is actually, since A21, the coefficient is 1, I swap row. To become, okay, I swap row 1 and row 2. And then my purpose, I want to make, okay, the cell A21, second row, first column, mean that phi here, the phi become 0. So the operation I did is actually, you can take first row multiply by phi, and then it's either you want to take row 1 minus with row 2 or row 2 minus with row 1 and put the result into row 2. Okay, so here, this one in PDF I cannot write anything, but you can see if first row I multiply by phi, I multiply by phi, so this is phi minus, I take row 2 minus row 1, phi minus phi. Okay, this one multiplied by 5, this is 0. So negative 4 minus 0, you still get negative 4. Okay, first row multiplied by 5, so 5 times 2, this is 10. 0 minus 10, yeah, minus 10. So this is the latest row 2. So after this operation, you notice that, okay, row 21 and row 31 become 0. And you notice row 2 and row 3 are actually equivalent. Mean if row 2, you divide by negative 2, then you get 2. This will get, okay, 5. So row 2 and row 3 reduce to the same row only. Reduce to the same row as what you have. Okay, let's see already. Yeah. So mean row 2 and row 3 actually equivalent row. You can, or I use a row operation 2 times row 3 plus row 2 you put in row 3. So row 3 becomes 0. Or if you look at just now, here, this one, when row 2 and row 3 actually equivalent row. Equivalent row, because row 2, if you divide by negative 2, you get 2. Negative 10, you divide by 2, you get 5. So 2, 5, same, okay, same coefficient, means row 2 and row 3 are actually same. Okay, or you can, row 3 actually same, then you can cancel the row 3, or you reduce a cell A3 to become 0 using the row operation that what I did here. So this is a row 2. Then from row 2, we have a negative 4y minus 10z equals 0, or y equal to negative y equal to negative 5 over 2z. If you let z is s, then y is negative 5 over 2s. And then, okay, you plug in z is s, y is negative 5 over 2s in the first row. So first row you have x, okay, plus 2z equal to 0. Z is s, so x plus 2s equals 0, x is negative 2s. So x negative 2s, y negative 5 over 2s, this is 1. To eliminate the fraction, you may multiply the whole vector here by 2. So first row become negative 4, second row negative 5, third row become 2. So this is a, taking s equal to 1, you have this is actually your V1. Then step 3, you substitute the lambda 2. Okay. So here, okay. Okay. This now. So V1, you obtain V1. Okay, lambda 2 is actually equal to lambda 3 equal to 5. So first step, you solve your, okay, A minus lambda 2I V2 equal to 0. So you minus the lambda at the main diagonal, what you get here. Okay, after that, you can easily see that actually row 1 and row 2 are equivalent, okay? Because if row 1, row 1, negative 4 here, you divide by negative 2, you will get 2, 0. So row 1 and row 3 are actually equivalent, okay? Or you can use the row operation to reduce the row 3. Mean actually, if you can observe they are equivalent, you can simply mean, okay, I delete the third row. Or this is actually reduced using row operation. Mean, okay, here 2, this is negative 4. Then, okay, row 3 I multiply by 2, so I get 4. So I add up, negative 4 plus 4. So mean I take row 1 plus 2 times row 3, then I put it into row 3. So you get 0. So it's either, okay, you can use suitable row operation, or you can observe, okay, from row 1, the coefficient negative 4 and negative 2 here. If row 1 I divide by negative 2, I get 2, 0. Because right side is 0. Okay, so you get same row 1 same with, okay, row 3. Hence, okay, 3 row, okay, 3 unknown with 3 equation, you reduce to only 2 equation. 2 equation. Okay. 2 equation. So you have from equation 1, from row 1, negative 4x, okay, equal to 0. Row 1, 0 times x, so 0, negative 4 times y. So 0 times z. So negative 4y equal to 0, or y equal to 0. Then, okay, for second equation, you have x minus 5y plus 2z equal to 0. So you plug in y 0 here. You have x plus 2z equal to 0, or x equal negative 2z. Then you let z is as x will be negative 2x. Okay, thank you. So z is what? Okay, y 0. Then okay, z is 1s. X will get negative 2s. So v2 is negative 2, 0, 1. Okay, the third eigenvalue, lambda 3, is actually repeated. Okay, repeated eigenvalue. When you solve, a minus lambda 3 I v3 equal to v2. v2 here you obtain here negative 2, 0, 1. Then okay, you put in lambda 3 is actually 5. So you minus the lambda at the main diagonal. 5 minus 5 you have 0. 0 minus 5, negative 5. 5 minus 5 is 0. Again, you can see that row 1 and row 2, okay, are actually equivalent. If row 1, you divide by negative 2, so you get positive 2. Okay, 0 divide negative 2, 0. Negative 2, you divide negative 2, you get 1. So row 1 and row 2 are actually same row. So you can cancel out the row 3. Or you can, okay, reduce the row 3 using suitable row operation. Here I use the same operation as, okay, previous step, 2 row 3 plus, okay, row 1. Mean row 3 I multiply by 2, so this is 4. Okay, add up row 1 and row 2, negative 4 plus, so I get 0. This one, of course, 0 plus 2 times 0, still get 0. Plug in, okay, third row here. So negative 2, row 1 plus 2 times row 3. Negative 2 plus 2, you still get 0. Okay, and then from row 1, you have negative 4y equal to negative 2. So y will be equal to, okay, positive half. Positive half. Then from row 2, 1 x minus 5y plus 2z equal to 0. Plug in the y value they obtain. So x minus 5 over 2 plus 2z equal to 0. Then, okay, if previous step 3 you let z equal to s, here for repeated eigenvalue here, just now we let z equal to s, here you have to let z equal to s so that you will get back the same v2, the same eigenvector, and the new eigenvector will be the v3. So you let z equal to s, here again you have to let z equal to s. So x will be equal to negative 2s plus 5 over 2. So x negative 2s plus 5 over 2, meaning you divide it into a vector depend on s and a vector which is a constant vector. Y is 0s, okay, plus half. Okay, z is 1s plus 0. So this is actually the v2 that you obtain in step 3. So the new, okay, vector is actually your v3. So So this one, this is V3, yeah, not V2. Okay, after that, okay, the solution is actually A V1 exponent lambda 1 t. So this is your V1. Okay, lambda 1 is 0, so it's only constant vector. B V2 exponent the lambda 2 equal to lambda 3 equal to 5. So B V2 exponent 5t plus C. Okay, see the lambda 3 is repeated, okay, repeated eigenvalue. Hence its solution is C V2t. In V2 same, V2 multiply t exponent lambda t plus V3 exponent lambda t. So this is a V2, this is a V3. So again, in the homogeneous solution, it may have a variation of answer, especially for repeated eigenvalue. Okay, I think maybe times if you have any question, you may just jot down, and then maybe times for you to do the, let's see. So next question.